Number one, the parent function is this. I see a couple of you doing, when you do the negative, you're doing over here. But remember, the negative is a vertical flip. So the negative actually bring you down to here. Okay? And then the 3 means you do it 3 times as far. If this is 1, this would be 3. And that's kind of good enough for now, for number 1. How do you do the domain? Domain would be x have to be greater than or equal to 0. So the domain range, domain is x is greater than or equal to 0. If there's no x on the left side, you would say range is y greater than less than or equal to 0. Then only y is down here. You never have a output that's above 0. Okay, number 4. How many of you are still working on number 4? If you're done, I'll come around and take a look. Four is a cube root, so it has an S shift, not just a 2. Yeah. It gets skinnier, it's stretchy. It's like you have a chubby kid that goes taller. He looks skinnier, but he's actually not skinny, he's taller.
So it's the opposite for
Right, because now if you think back on the quadratic, you're actually stretching this way.
So parent function.
Yeah. Parent function is that exact equation. So it always looks that way. So number 4, first you need to know that the parent function will always look like that. And simply the 4 is just a vertical stretch, which now gives us something like that when we're done. Okay? Yeah. Because you're doing x cubed after cube. Yeah.
It's not a graph because it's an exponential.
Exponential.
Like,
Exponential? No, these will actually be.
wait, because
It's a exponential decay. No, exponential decay would be x. It will be exponential, but it's different. Yes, I'll say yes. Domain for this is all real for both. Okay, then all value of x as possible. It will give you all possible y.
Why is it not so?
For number 1, it's
Okay, number 1, your n graph looks like this. This is the only graph that we actually care about, right? The only x you can plug in, these will give you undefined. The only x you can plug in is 0 and beyond. And the only y you'll get is 0 and under. So you would say x greater than or equal to 0, y less than or equal to 0.
So you don't say all.
These one you say x all real, y all real.
Also for negative, you say
Depends on the graph. If your graph is just this, which means your graph looks like that, you would say x greater than or equal to 0, y greater than or equal to 0. It depends on where you actually have that data. Okay, let me see what's the rest of it. So the rest of it should be familiar to you. I'm not going to go into details. Right? A is horizontal stretch. H is horizontal, vertical stretch. Sorry. H is horizontal shift, K is vertical shift. So when you have this, that means you take the parent function, you change it to negative, and then -2, that's a stretch. Move it 3 to the right, up 2, because of H and K, and then you draw the same graph as this one. Okay. That part is probably more familiar to you than the beginning of this chapter. The rest are all examples. Okay, there's your homework. Again, I'll post it on Power School. Yes.
What do we do with the K?
K is up and down shift. Just like before. Before you had
H is horizontal.
a x minus h squared plus k. Now you have a x minus h plus k. Same thing. So horizontal shift, vertical shift. Horizontal shift, vertical shift.
So, do you want tea for tomorrow?
Sure.